Hey guys, in this presentation I'm going to show you guys how to use Fusion 360, a CNC router, and a laser cutter to come up with some inlay designs similar to this on this ukulele neck. Obviously, goes without saying, you're going to have a little bit of material in your classroom or wherever you're working at to do this. CNC router for sure, laser cutter. You can do both of these with a laser cutter too. And I would say the laser is probably on the cheaper end of things that you can buy. But with Fusion 360 and a little know-how, you can make stuff like this and even more intricate stuff. So let's dive in and take a look at how I've done this. And then I'm going to show you guys a sped up view of how I've actually created it. Creating something like this, just inlaying my initials into a fretboard. And if you guys want to see a more detailed version of this, shoot me an email. I'll be able to send you one. There's not so much I can show you in 15 minutes, so I'm going to get as much information as I can down close to 15 minutes. And again, if you don't understand or you have questions, feel free to let me know, and I will definitely reach back out to you and give you any information that I have, because this stuff right here, pretty daggone cool.
All right, so right now I have a model of a 25.5-inch scale length fretboard. I have the sketches here all laid out for the nut slot. The nut slot is three-dimensionally added to this. Notice that there is a 12-inch radius here denoted by this sketch. It's extruded through to a 12-inch radius. And we're going to create, or attempt to create, a really small inlay here on the 12th fret. Keep in mind that this is a very, very watered down version of this presentation. If you'd like some more information, shoot me a message and I'll be able to create a longer version of this to actually show you exactly step by step. But this is the idea of what we're going to do. We're going to create an inlay here of my initials TW on the 12th fret. Of course, obviously I have the fret dots laid out here, but keep in mind that's going to be negated. So what we're going to do here is we're going to create some some tool paths with Fusion 360 in the CAM or manufacturer environment. And one thing that I want you to notice is that you can go back and forth between these environments at any time. So if you make a mistake and you want to go back into the design environment, you can definitely do that. So what we're going to do here is we're going to create a sketch of my initials here. So I'm going to create a new sketch, and I'm going to sketch on the XZ plane here, the top of my fretboard, and I'm just going to go to create, and I'm going to choose text. I'm going to left click, hold, and drag out, and then I'm going to, in the sample text here, I'm going to put T space W, and I'm going to select this and find a really thick font. You can use any of them that you want. You don't want to use any of them that have a lot of a lot of different like curves and things that are going to be hard for the machine to mill. I'm going to choose Arial Black for today, and I'm going to make the height of this 0.5 of an inch because it's basically about what I need. And then what I'm going to do is I'm going to hit OK. Now we have to think about this a little ahead. We're going to need two of these sketches. So what I'm going to do here is I'm going to right click on this. I'm going to choose copy. You can also hit Control C on the keyboard, whatever. I have this copied. So we're going to move this into the 12th fret for right now. So I'm going to hit M on the keyboard, and I'm going to move this in. If you had a center line drawn on your actual model here, you could use the midpoint constraint to make that exactly in the center. But for today's presentation and to save time, I'm just going to eyeball it to where it's really close. Obviously, you're going to want to spend more time on this than I do. I'm going to hit OK, and I'm going to choose Finish Sketch. Now, if you remember, I have that other thing copied. I'm just going to move this box a little closer, hit M, get this thing roughly where it needs to be. And again, I still have that one thing copied, so I need to make sure that you understand why. Well, the issue is that we need a secondary version of this sketch over here to create the actual inlay. So what I'm going to do now, I'm going to choose Create a New Sketch here. I'm going to then choose the XZ plane again, and I'm going to hit Control V on the keyboard, which is going to paste that in there. You can also right click and go to paste. I'm just going to move this to the right hand side, and I'm going to hit OK, and I'm going to hit Finish Sketch, and I'm just going to hide that sketch for right now. Maybe we'll just we'll name that sketch inlay, and we'll name this sketch right here Pocket, just so we know what's going on. So here is the inlay pocket. And again, the cool things about Fusion 360 is the fact that when you create these sketches or these texts, it automatically comes in as sketches. So what we want to do is we want to extrude this down. I'm going to hit E on the keyboard, and I'm going to extrude it negatively. And my inlay is I will do 0.1 inch, and I'm going to hit OK. So notice here that I have a ton of different things that I would want to do with this fretboard with the CNC router. I'm going to want to cut the frets, I'm going to want to cut the fret dots, the nut slot, and the radius, as well as the contour of it all. And this is going to be added to the toolpaths. So one thing that I want you to understand is that you probably want to cut this pocket before you do the actual radius of the fretboard. And then you'll want to cut this pocket, inlay your inlay while it's still on the machine, and then cut the radius. That way it cuts the radius or the inlay of that to the same radius as your fretboard. Could you get by with just inlaying it in there and using like a radius sanding beam or something like that? Absolutely. But I like to work smarter, not harder. So now that I've created this pocket, I'm going to get rid of sketch 1 here so you can see. One of the things that you have to understand is that a round tool is not going to fit in this square pocket really well. If we were going to be working on the outside here and we were driving a 23 thousandths end mill, in this case what we're going to be using on the outside of this, we could definitely do that external point there very easy. However, when you get into these internal ones here, such as this pocket or this if we're doing the plug or the inlay, these little things here are going to be impossible for the tool to get into, and the G-code that you generate, the computer is going to know that it's going to drive it up there until the radius of that tool hits both sides of that, and that's as far as it's going to go up. It's not going to go up and ruin your pocket. So if you're using strictly a CNC router, what I would recommend doing is going into this pocket and clicking each one of these edges, holding shift on the keyboard, and select all of these edges. Again, holding shift. So they're all selected. Now what I'm going to do is I'm going to hit the F key for fillet on the keyboard. So F. And then I'm going to drag this in. Again, you could probably do, actually Fusion is actually pretty cool. You can do 0.023 divided by 2. So there is the radius that I would need to make that happen. So the tool will actually go in there and cut that away. But in my experience is that while using a laser and or a CNC, that the kerf of it actually causes that to kind of be rounded anyway. So I usually just cut it the way it is, and it usually fits in there perfectly. The worst case scenario is on your inlay, you would have to take a little bit of sandpaper and hit the corners before it to fit in there. But guys, again, this is a very quick presentation, so we're going to work with this. Again, once you do this, more and more, you're going to get very good at it. So I've created my pocket here. Now it's time to set up the toolpaths. This is where Fusion 360 is really, really cool. They've actually upgraded this version or these environments of Fusion over the last few years. So it actually makes it a dream to use. I'm going to choose the manufacturer environment here. I have this plug or the inlay, the actual pocket here, and I'm going to work on creating that first. Again, what I would do is I would create this pocket while the fretboard was flat. I may even actually do this one in the very first toolpath. And then I would put my inlay in there and then cause the CNC router to do the radius. That way it would radius those inlays as well. But what you have to do is you have to create a setup. And a setup is basically a computer-aided manufacturer setup, and it's how your system actually runs. And it is very imperative that you find out which way your X, Y, and Z axes actually work on your machine. In my case, Y goes left and right, X goes up and down, and then Z goes away from the bed. If you don't have that set up correctly, and you have this set up, and it's cutting say like you're wanting to cut something into the fret or the body of your guitar, and you have that set up wrong, it's going to cut the inlay in a place that you do not want. So I'm going to choose setup. I'm going to choose new setup. First thing is machine here. You could select the machine if you have it. My actual router is not in here, so I don't select any machine. It's not really going to matter. Now the WCS, the work coordinate system, this is what I was talking about, how you must understand how your machine is working. Again, left and right here is Y for me. Up and down here is Y, and then away from the material is Z. So instead of choosing model orientation, I'm going to choose select X and Y axes, and I'm going to choose for the x-axis, I'm going to choose which is now the z-axis, but I'm going to choose that to be the y-axis. The x-axis is going to be, or the y-axis, I'm sorry, is going to be the x-axis now, but I'm making that the y-axis. But if you notice here, the z-axis is going through my material away from this, so that's not exactly what I want. So I'm going to have to flip one of these axes to actually make it actually work. So I'm going to choose to flip the y-axis, and in my case, that's the way I want it. I want y pointing right, x pointing down, and then z pointing away from the material. Now, the next thing right here, the origin, this is totally up to you how you set this up. It can be set up any way you want. It depends on how you origin your router or your laser of how you want it. I always choose the very top, very center of my stock. So I'm going to choose stock box point. I'm going to choose box point, and I'm going to zoom in here, and I'm going to grab this little point that's in the center here. That gives me the origin point. And then the body's already selected. Everything's good. The next tab here is the stock tab. When you click on here, this is going to give you the option to set up the stock however the big is the size of the stock, the piece of wood, or whatever you're cutting this out of. Normally, it sets to relative size box, which Fusion tries to take a box and make it big enough for this actual thing to work. My favorite thing to do is choose fixed size box. And the stock that I use is 20 inches long, 2 3/4 inches wide, and the height is 0.3 of an inch. Now, one thing that you have to do here in my case is that I use the bottom of this board to be the bottom of the fretboard. So I want the excess material to be above the fretboard. So in order to do that, you have to choose, normally it's set to center. And if you pay attention here, there's a little gap in between here. So what's going to happen is it's going to cut this fretboard, the radius and stuff. So what's going to happen is it's going to use the radius at the top, which is going to make my fretboard too thick. So my model is exactly 1/4 of an inch thick here. So if I don't ground it to the bottom here in the z-axis, then I'm going to mess it up. So I'm going to make sure that I choose here offset from -z, and I set that to 0 inches. So it's at the very bottom there. And once I have that done, I am ready to rock and roll on the toolpath. So that's one setup. You're going to need 2 setups for this, but right now we're worrying about the pocket here. So what I'm going to do is go up here into 2D, and I'm going to choose 2D pocket. The very first tab here asks you what tool you're going to be using. For my case, I'm going to use a 23/1000 end mill. As I mentioned earlier, I think I mentioned, but I'm going to mention it again, I cut at 20 inches per minute, and I cut at a depth per pass of 0.015. Again, that's totally up to you. What size bit you use, the feed and speeds is going to be totally up to you. So I'm going to choose the tool here, and my tool is already set up here in my library. It's a 23/1000 end mill, and again, it cuts at 20 inches per minute. The spindle speed, I'm going to run it at about probably 15 to 17,000 RPMs. I find that the smaller bits run better if they're run at a really high RPM. And make sure you have this stuff set up how you need it for your tool. So I have that selected. Obviously, my CNC router doesn't have coolant. But again, if your tool changes the spindle speed automatically, you're obviously going to change this here. Mine, it doesn't. I have an external adjustment, so I'm not really worried about that. Next is the geometry. What would you like it to make the pocket out of? Well, I'm going to select this. I'm going to select this. Everything's good there. The next tab is heights. You don't have to worry about that. That's basically clearing heights, retract heights. I find everything in here is actually fairly good for my machine, so I leave it. This next tab here, however, the passes tab, is something that you definitely need to go into. You're going to choose multiple depths here, and again, I set my depths at 0.015 of an inch. That way it doesn't break the bit. If you don't choose multiple depths here, what's going to happen is it's going to drive that 23/1000 end mill. It's going to ramp it down and then try to make it a full depth pass, and I can guarantee you that tool is going to break. So once I have that all set up and I hit OK, eventually it will generate the tool paths that I need. So there is the very first tool path and setup. So I'm going to call this the pocket setup here. And then I have to create a new setup. But if you remember, back when we were working in the design, I had that secondary inlay over here. So I'm going to turn that on to make sure that I have access to that. Again, first off, you don't have to go back to the design environment to make that happen. If this is turned off, you can stay in the manufacturing environment and then just drill down models and then find your sketches, and you can turn it on that way as well. So now I'm going to work on this. So I have to create a secondary setup. So I'm going to create new setup. And I'm going to choose the model here is here, but there's no body. So what I did was I forgot to make these a body first. So I'm going to extrude these by hitting E on the keyboard, and I want to extrude these into three-dimensional space. So I extruded these -0.1 to make them fit here. In all reality, if you were to make this the exact same size to fit in here, it wouldn't fit. Obviously, if this is the exact same width here as this is, it's not going to fit. However, I found that the laser kerf or the CNC router bit actually causes a little bit of kerfing there, so it does fit in there very well. So I now have these two bodies here, and again, what I'm going to do is I'm going to go make sure I'm in the manufacturer tab, or the environment. So this setup here, I'm going to create a new setup now that I've created those two models. Choose the model here, and then the stock size here, it automatically wants to choose from preceding setup. That's over there. We don't want that. We want to create our own. So I'm going to choose fixed size box, and within this is going to be the size of the material, again, that you're cutting the inlay out of. For my case, I'm just going to put 1.5 by, let's see, a ½ inch should work. Or I'm sorry, height, and then let's see the depth of Y, which is going to be the thickness of it. Let's just make this 0.1. I will just thickness my material down to the exact thickness that I need, and that'll save me a little time. So I've set that up. It actually could be, a little different, whatever. This is totally up to you, and again, this is a very quick overview. Next thing you're going to do, make sure you set the model position where you want. And we're going to make sure we go over here and change the stock point to the center of the stock. Again, it's totally up to you how this is done, but I'm also going to change the model orientation to my X and Y to make sure that I am getting the X and Y axis that I need. So I'm going to get this set up, and then I'll show you how to create the toolpaths. Now that I have everything set up how I want it with my material and my stock and everything, I'm going to hit OK. Now, this is where Fusion actually is really cool, because I have these 3D models here, and I can actually create toolpaths from these 3D models. So I'm going to go over here to 2D, and I'm going to choose 2D contour. It's also right here. So 2D contour, same deal. Choose the tool, set up everything you want, just like previous. The geometry here, we're going to choose the outside profiles of these two models. We're going to go over to our passes, change multiple depths to your depths, 0.015 in my opinion, or in my case. Depending on, again, your feeds and speeds are going to be up to you. And then I'm going to hit OK. So now I've created these two toolpaths that I need and two setups. Well, the cool thing about Fusion is that I can actually export these separately. So what I'm going to do is I'm going to go up here. I'm going to make sure that Pocket 1 is selected here, where it's actually made active. And then I'm going to go up here to Post Process. And then the cool thing about it is, again, you'll choose your flavor of G-code that's actually exported to your machine here. Totally up to you how that's done. Mine is a shopbot, so it uses OpenSBP. You're going to change the name of it here, save where you want to. But here's the cool thing. You can go into operations here and choose which operations you want to use. So, for example, the pocket here, this is going to be cut into the fretboard, so I'm going to cut this out of one piece of material, and then I'm going to cut this out of another piece of material. So that is very, very handy. I would probably want to cut this out first out of another piece of material. That way I don't have to re-zero the actual axis on this pocket. So if I cut this out first, I'll have the inlay that I can put in this pocket. But in order to post-process this, choose whichever operations you want, hit post, and then take it to your machine. So let's go look at some sped up footage of that, and I'll show you the end result. Guys, that's pretty much it. If you guys want to know any more information, let me know. Sometimes your machine, you have to actually either make the pocket a little larger or the inlay a little smaller. You're just going to have to work with that and work with the machines you're working on. But if you guys have any questions, again, reach out to me. I'll answer any of them that I can. Before long, you'll be putting inlays in guitars just like this.